In this presentation segment, I'm going to focus on what climate change science and scientific modeling tell us about sea level rise in the Boston area. I'm going to take a distinctly local perspective on sea level rise and share maps and models of potential flood areas in Boston. Then discuss mitigation and adaptation strategies. We developed the maps that I will be showing using discrete heights for sea level rise that were presented in the previous segment. 2.5 feet of sea level rise, representing approximately the higher projections for mid-century, and 5 feet of sea level rise, representing approximately the higher projections for the end of the century. Additionally, we mapped a 5-foot storm surge on top of sea level rise, which represents approximately the current 100-year coastal flood in Boston. And all of these maps represent a wicked high tide, the bi-monthly astronomical high tide. These maps are two-dimensional representations of a three-dimensional phenomena. So what we use for our symbology is a profile view, a side view of the maps, which are shown from an aerial view, the view from above. So on the maps I'll show, areas shown in the pale yellow indicate flooding of up to 2 feet of water. The red areas in these maps depict 2 to 4 feet of flooding. The mustard color areas represent flooding of 4 to 6 feet. And the dark blue areas represent the areas of deepest water without regard to a specific depth. The map shown here represents the worst of what Boston experienced during Hurricane Sandy. And it also shows approximately a 2.5-foot sea level rise above the normal height of a wicked high tide. Sandy's storm surge at high tide in Boston was just lapping at the shores. If you look carefully, you can see a little bit of pale yellow, less than 2 feet of flooding, down around the edge of the waterfront. There's two other ways of looking at this map. The first is that mid-century, sometime when we've experienced 2.5 feet of sea level rise at wicked high tide, the fringes of the Boston waterfront will flood regularly. Morrissey Boulevard, for example, on the other side of Savin Hill Bay, will be much more flooded than it is now, twice a month. Another way to look at this map is that it could also represent a current small coastal storm that generates 2.5 feet of surge on top of wicked high tide, which is what happened during Sandy. Now let's look at the map of flooding during wicked high tide after 5 feet of sea level rise, projected to occur approximately at the end of the century. We can also look at this map in several ways. Under the high sea level rise scenario, this map shows the twice monthly wicked high tide in Boston by the end of the century. Another way of looking at this map is that it approximates today's current 100-year flood. On this map, you can start to see flooding in areas of the city that were created by historical landfilling. One important thing about this map is the Charles River Dam. The Charles River Dam was designed to deal with today's 100-year flood. It will not currently flood in the Back Bay during a 100-year coastal storm, but consider what could happen with future sea level rise. Now we're going to look at them all together. Here we see our model of 2.5 feet of sea level rise with a 5-foot storm surge during a wicked high tide, which does show the overtopping of the Charles River Dam, which will then flood Back Bay and Cambridge. This map shows that Boston could become very vulnerable to coastal flooding by approximately the year 2050. This would be a good time to address adaptation and mitigation. We should start with definition of terms. Mitigation is what we all need to do. We need to stop emitting carbon dioxide at some point, hopefully sooner than later, to mitigate this problem. We have to solve the problem of excess carbon dioxide in the atmosphere. Adaptation, which is what our research group focuses on, addresses the fact that climate change and sea level rise are already happening and likely continue on into the foreseeable future. We need to figure out how to live with this, especially in coastal cities. Our research focuses on the hard structures of the city, specifically Boston and specifically sea level rise. But these adaptation concepts can be applied to many situations. One of the challenges we deal with in adaptation science is the uncertainty. We saw earlier on the sea level rise graph that the further you go out into the future, the more uncertain we are about when and how much sea level rise will occur. So we need to be able to respond both in different locations as well as over different periods of time, and we need to include all the stakeholders. We need adaptation options that are flexible, adjustable, and robust so that no matter what happens in the future, the solutions that we implement are solid. The other piece is to integrate adaptation with sustainability planning. While you're adapting, why not do a little mitigation at the same time? Consider involving things like green roofs and consider other strategies and activities that you can build into adaptation planning. The new Spaulding Rehabilitation Hospital in Charleston is a great example of these types of integrative adaptation strategies. When the hospital committed to building on the water in Charleston, they acknowledged the problem of sea level rise right up front during the planning process. Their engineers determined what would be their 100-year flood elevation in the year 2085, and they located all of their key floors above this elevation. Every area below that is not critical. A flood can damage it, and it wouldn't stop the primary mission of the hospital. Even better, mechanical, electrical, and emergency services are located on the roof, isolated from the flooding and the waves during a coastal storm. All operative windows are keyed to open in the event of system failure. That's a direct response by hospital designers to Hurricane Katrina, where they had to break windows to get fresh, healthy air for patients when the power went out for many days at a time. I'll finish this presentation with one of our key findings from the Preparing for the Rising Tide in Boston report, that we need to coordinate adaptation planning among all sectors of the community, because no one group or organization has the resources, knowledge, and authority to complete the task alone. I'll also leave you with one of my personal favorite adaptation credos: prepare and monitor. Start researching and evaluating the potential problems now. Develop plans now for how to adapt to these issues in the future. And then, when the tide gauge tells us that the sea level rise has reached a critical threshold, then implement the plans that we have already developed.